Miss Richardson.
Mr. Tyler. Mr. Tyler.
Yes, can you hear me?
Yeah, I'm gonna be on my phone. I lost my Capri charger. I gotta find it
Okay, it's gonna be kind of hard to do the work. I hope you can keep up. Do you got Google Docs on there?
on my phone. Yeah.
Okay. So we're gonna begin and try to give everybody 3 more minutes. All right.
Too close, spray, knock out smell.
Hello, it's me.
Hey, Mr. Tyler.
Okay, that means everybody else is gonna be late or absent. So it'll probably trickle in later. Um, let's see. Share the office. Make sure it loads. Then why didn't that save? What's going on with this? Okay, all right. I think that's fixed. There we go. Looks a lot better now. All right, so let's get our norms out of the way. There we go. Okay, so the five basic norms. All right, can Miss Richardson, can you read the five basic norms on the screen? Can you see it?
Yeah. No one has the right to hurt another person. Education in the classroom are sacred. We will never behave in a way that discredit ourselves, our school, or our families. In Excel Academy Southwest, students are always a lady or a gentleman. We take pride in Excel Academy Southwest.
All right, thank you, Miss Richardson. Oh,
Right.
Tamia left. Okay, I guess I'll do the next five. So five academic norms. Oh, there she is. I was
I
about
help you out, Tyler. You ain't never alone.
She's. I'm trying. Well, give her a second. I'm trying to see if she wanted to read it. But I appreciate the support. Give her one more moment. That's her again. Are you okay, Tamia? You keep going in and out. You there? Okay. Go ahead, Rush. You can go ahead and read for us.
All right, which one we on? I just got in here.
The
Which one we on?
five academic norms, sir.
We respect the opinions of others. We respect the culture of the classroom. We are attentive and participate. We have high expectations of ourselves, our peers, and our teachers. We are here to focus on preparing ourselves for post-secondary endeavors.
Yes, sir. Okay. Thank you. Thank you. Appreciate that.
Ain't that
So
right, Ariana?
are you there, Mr. Richardson?
What he say?
I say, ain't that right? All that stuff I read, ain't that right?
Yeah, that's right.
All right. So, Ms. Richardson, we're going to be doing the assignment today inside of welcome to class, Miss Franklin. I got to go back and do attendance again. I hope Tamia comes back. As a reminder, everybody on Thursday, there's what we call asynchronous days. So, definitely be here on that day so you can get caught up because it's kind of like an office hour. That's a day I'm not trying to just show you how to do stuff, right? I'm helping you with stuff you probably didn't get done yet. And that's how asynchronous days are, but we'll see how it goes on Thursday. So if you still have nothing done, don't worry. Focus on today's assignment, and then we'll tackle anything you're having trouble with or try to on Thursdays. Okay, so let me save this to the system. It didn't save it. Okay, let's just do this then. Better. Okay, there it goes. All right, so today's assignment, right? You go to SB, and here we go. And inside of SB, you have some options you want to choose. This is third period, right?
Mr. Tyler, you know you're gonna have to put the stuff in the chat for me.
You mean the question?
Yeah.
Okay. Mm, let's see here. So you can get that and do that right now before I get too far along talking about how to do the problem and stuff. So the two problems you're going to need are 1S and 2S. But before I put that in there, I want so don't put the rest of it. Just put the questions in there. But for a couple of points, can you read what I did put in the chat? Because it gets us started on today's assignment. Let me see if I put it in there right. Did it go? Oh, and it cut some stuff off. 1 second. So B, darn it. B is times 10 to the, there we go. That's the rest of it. Okay, got it. Put that there. Okay, yeah. So can you read that first section? Like all the way down to charge for the entire thing. And that'll be 25 points, Miss Richardson.
Yeah. I found ghetto. I'm sorry.
Mhm.
Um, what you put in gray or at the top?
Start with hello.
Hello, all future electric engineers. Sickness problems are ready to be completed and are ready to present tomorrow in class. And sickening problems have to be completed as homework and will be checked tomorrow in class as well. You want me to read the problem too?
Yes, ma'am. It's 25 points.
Oh, okay. Hold on. A uniform electric field established by connecting the plates of part a
Parallel.
parallel plate. Why you? Never mind. Um,
Parallel plate capacitor.
capacitor to 12 volts battery. A if a plates have a. You gotta say that
Separation.
because I can't really read it because it's so little.
Separation.
Separation of 0.75 centimeters. What is the magnitude of the electric field in the capital? Is that
Capacitor.
be a charge plus 6.27 times 10 6?
To the -6 power.
Can you say that? Because I don't want to say
To
the
the
power
negative
wrong.
right, so to the -6 power, coulombs moves from the positive plate to the negative plate. Find the charge and the electric energy for this charge. So I know this was kind of hard for you, but you tried it out.
Right,
So
where is all the kids at?
where's all the kids at? Oh, they playing hooky. I don't know. They absent. You're here. That's all that matters. Okay, Sharon came back. Somewhere where all the kids at. You worry about where how you gonna get all this work done. Because some people are watching the videos afterwards and still try to turn in, but that's a different story because it still affects their grade by attendance. What was I saying? So I put the questions in there. I put one of the question in there. So let me put it in here again for you. So the first question all together is, all right, let me grab this. Let's do this. Okay, so that's the first one. And then the second question was, and she just read that. Because I don't want to overload the chat. I got to grab just what I want. All right, so now you got an idea of what you have to put into your Google Doc, right? So now we're going to set up our Google Doc, and you guys should be used to this by now. So resize my screen, open up Google, and I'm gonna make sure I'm logged into, of course, my the account I need. That's what you should be doing. If you're on your phone, you have to load it as Google App already. And first thing you want to do is open it up. So log in and then open up your Google Docs. And once you get in there, of course, open a blank document and establish a new document to type on. Okay, so now it's that established. You got first thing you got to do is what? We got to name our document. And what else are we going to put here? We're going to it's a date. So it's the 1st of December. Wow, time flies. And now we put our header, right? It again, that's the 1st of December. This is the same procedure we've been doing since the start of the quarter. Period. And you should put what, 3rd, right? And you are intro. To engineering with robotics students. First session is last session is a 5th period. Okay, so now we have that much. What you want to do is you want to make your title, and the title is usually right here. Is do now plates at different potentials is the title, in case you didn't know. Because I know you're using the phone, so I'm trying to help you out. Usually, if you're on a computer, you can switch screens and you can see all this. So I'm gonna type in the title, and then we see that was plates right, at different potentials. Right, and we're gonna center that. Okay. Exit slip is what? Change the resolution real quick. So exit slip, what is that composed of? Well, the classroom term of the day, which we've discussed, I think in Townhouse. No, I'm sorry, that's the word of the day. Classroom term of the day, I'll tell you what it is in a moment. But that was in the brackets in ESB, I think. I usually try to stay consistent with that. So classroom term of the day is, and we got the word of the day. Hello, Mr. Stevenson. Word of the day is, all right. So back and mark him present. Okay, so Stevenson's here. All right, so what do we do? That's why I put those two questions in the chat, right? So all you gotta do is take them or go to Edsby. And if I come here, you'll see in Edsby, the questions are there. You're only taking one S, the synchronous. We're gonna do that in class together. And then asynchronous, you're supposed to do it on your own. It's just practice to get you ready to tackle this type of problem, many other problems on Fridays. All right. So let me grab these two questions. I'm just going to copy these two questions from Esby into the Google Doc. That's what we're about to work on. Okay. There. And at this point, you should have just what I have, if not a little bit more, right? You have just this much. Let's make this 14 so you can see everything. All right. But what did I do? Well, welcome to class, Mr. Castro. So what did I do? I just went through and slowly um, put together the document name, right? Do now, the date, and then the header. You gotta have the same header as me. I see people don't put all this stuff in there. I don't know why. Um, what else? The title, the exit slip. Oh, I forgot to go back to that, right? So what is today's exit slip? And then there's also the opportunity to get 15 additional points for the objective. Mr. Stevenson, you just got here. I want to see if you can read the objective on the screen. Let me put it on the screen for us. So you click on me, and then we're going to click on CTE over here. All right. So can you read the objective that says agenda on the screen there, Mr. Stevenson? It's in gray. Is your microphone working? Seems like it's not. All right. Well, what about you, Mr. Castro? Are you able to read what's in the gray box there? It says agenda.
Today's objective, students will be able to analyze the connection between the electric field and the electric potential.
Thank you, sir. Thank you. And let's see here, Miss Franklin, can you read what's in the white box that says classroom term of the day?
Classroom term of the day is electrical energy potential. That's the word.
Potential.
Potential.
Hmm.
What?
Potential.
Potential. Word of the day is infer. Infer.
Her. Thank you. All right. So 10 points for her. Now, those are the two things you all will need. Now, if you take this objective and you put it into your document that you turn in, that's 15 points. If I see it in there and I'm grading it, it's 15 extra points. Also, the definitions of electric energy potential and infer, you need to get those to get an additional 25 points. All right, so let's go back to the Google Docs so you see it. And this slide deck is already inside of Esby, everybody. In case you need it, let me put it in the chat. And you can just, if you save it, you can always utilize it. It's very helpful in case you forget the objective, the word of the day, and things of that nature. Let me grab this. Put this right here. There you go. Okay, so you could always utilize that. I'd bookmark it and save it for later. It's a quick one-stop reference. Now, the document, right? We got all this started, and then I want to jump into the notes and how to calculate everything. But first, we got to do a simulation because I think if we don't do the simulation first, things are getting lost in translation, or you just won't get it done, right? So let's get the interactive part out the way, and then we're going to do the calculation for this particular problem. Some of you have had the class before, have seen this before. Some of you haven't. So, don't spoil it for anyone, but just do as I say. We got to take 2 snapshots and put in the chat the simulator you're going to use. Okay, so I want you to click on the next link that I'm providing and then open it up so you have what I have on the screen. We're going to do one snapshot with the capacitance, and then the next snapshot is going to be the light bulb situation. So let me know when you all are there yet. You should have already, everybody should have pretty much done their doc though, like, because we're going to take our snapshots from the simulator and put it right into this document we've been doing this whole time. Okay, so take a moment and get that started. Okay, so let's see here. Stevenson, are you there? Because I was like trying to get you some participation points and you didn't say nothing. Did you fix your microphone or are you still out? Okay, have to come back to you. All right, so I think everybody is where I'm at. I slowed down for a second just to let you get caught up. You should have this simulator going. You can click on capacitance, and all you're gonna do is you're gonna adjust the battery. You gotta do what I'm doing. Everybody, I'll be following these steps. Give it a little bit of voltage, and if you notice you get a voltage, you see these charges on the plates. All right, so you adjust it up and down, and you'll notice what's going on with each plate. Once you give it maximum voltage, which is 1.5 volts, okay. Next, you're going to turn on some other identifiers. All right, so we see how much stored energy. We use what is called joule for energy, and then coulombs for charge, and farad for capacitance. That's if you actually have a capacitor. Next, we're going to change the plate's area and separation. This is what the problem is talking about, the separation. Notice the separation increases or decreases the energy stored and other values above. If I at least let it charge for a moment and you come here and you deselect this, the charges will stay there. This is like having another battery you created waiting to be used. In fact, if you turn off certain TVs, you'll see that the light goes off slowly. In fact, if you unplug a device and it has a capacitor on board, the light will still go off very slow because it's a drain of the energy, all right, or the charge. I'll take this measurement device and make sure you can see electric field. I forgot to tell you that. So the electric field is what's in between creating this exchange of voltages. So I'll take one of the leads here, and I'll take one of the leads here, and I just want to measure what's in between here. Now, we gave this about 1.5 volts. It's stored, in actuality, 3.26 volts. All right, so that's your first snapshot. I want you to set it up the same way I have, and then you come over here and take a screenshot. Once you do that, it'll download a picture of the setup that you see. Okay, so let's see here. We're gonna come over to our document, and that's gonna be our first insert. So I did the screenshot first. I hope you guys did too. You click on insert now, image, and you go upload from your computer, and you find the image you just downloaded. So you give it a moment, it makes another menu pops up. And we're gonna click on the capacitor lab, just open it up. And there it is, et voila. Okay, so that's that one. We got one more to do. Did everybody get this? Because I don't want to move too fast. Like, did everybody get their screenshot? You know, some people said they were on their phone, like Miss Richardson. Did the link work for you? Were you able to open it up? Are you able to take a screenshot?
I just screenshotted it like that.
You say what?
I just screenshotted it.
Okay, but you can't open the simulator. Or did you ask me how to screenshot it?
No, I was telling you I screenshotted it.
Oh, you did. Okay, I couldn't hear you too well. All right, so that's one of them. If you set it up like I did. The next one you need before we do the problem is the light bulb situation, right? So what do we do here? Well, same thing. Let's give it some voltage. Let's turn on the electric field so you'll see that exchange in between the plates. and also these other values, so you can see what's happening there. So what are we going to do? Well, we want to be able to power this light bulb, so I can toggle this switch here, and they both work at the same time too. Where it's not engaged with anything, and then I can drag it over again and engage it, and there's a light. Now your goal is to get a light bulb snapshot before the light bulbs, the plates and the charge, they all dissipate. So let's try that again. We got to charge up the plates by connecting it to the battery. Looks like they all are charged. We can give it even a little more by stretching out the plate area and separation. Right. So we want maximum. If I pull the plates all the way together, you see I got a lot of energy I can use this time. All right, so let's disengage and connect it to the bulb. And you got to hurry up, come over here and take a screenshot before you lose it. Okay, so I got my screenshot. But you see the energy's draining. Okay, now that is your second and last screenshot. So let me come out of this. For some reason it's like on full screen mode. Did I take the screenshot? I don't think I did. I think I hit full screen by accident. So let me do that again. Connect it. It's fully charged. Okay, put that there. There we go. I'm like, man, I didn't take a screenshot that time. And if you're using the app like I'm using it, you click on this FET logo over here and you go to screenshot for screenshot. Now we're going to put this picture in our document and start working on our problem. It is 12:48. Whew. That's why I want to get that out the way, because we got here at 1:20, so we got a little time left. All right, to knock this problem out. All right, so the second image is going to go in. I'm going to click on, let's see, insert. And then I'm going to grab that and I'm going to upload from computer. And I'm going to put that second one in there. So this is the second image. All right, so you should have just two images at this point. Now I'm going to go through the steps you need to solve this problem. Is everybody still with me? Because we got a few more things to do. And we got about maybe 30 more minutes of class left, I think. Hold on. So 50, no, it says 48. Yeah, because we got it at 120. So we got about 20 more minutes of work to do. And we might be leaving a little early, but we got to get all these steps in. And it's just pretty quick. It's not a lot. You don't believe me when I say that. So the first problem, I'm just going to start typing right here above the picture so you can see all the steps. We got our images in there. So the first problem, you need some background knowledge. We said it in our objective. You understand the connection between the electric field and the electric potential. And those are the plates, the potentials. All right, so we're going to go through and pull some values out. But first, you need an equation to calculate all this. And the equation for such is same thing as before, as yesterday. And what is the name of this equation? I should say that first, right? So this is the equation for the connection between the electric fields or field and the electric potential. That's this definition here. What we're doing is expounding more upon what we've done before. Okay, so that's E for electric field. That's the equation. I'm giving you the terminology. Electric field is equal to minus, I'm going to put this in parentheses, the first value is the change. And change in means we're going to use delta again like we did yesterday. So change in electric potential. Welcome to class, David. Potential, right? Close parentheses, divided by, right, the distance. You could say, it was ready to say between plates, but you could say that. Let me take a moment, slow down. These are the first set of notes, everybody. And I got to tell you what it's measured in, and then we do a known and unknowns, and we finish the problem off. So let me just mark David present now. Yes, I know I'm presenting. Thank you for reminding me. Okay, there. He has David's. Okay. Now, what was I saying? I was still going through the notes. And again, if you miss anything, I'll try to go back and recap. David, the only thing you missed is the part where we did our simulation. So, where was that? So, we'll go back and I'll show you where the simulation link is and what you need. Okay, so where are we at? We got to talk about what these each are measured in. So, for electric field, it'll be in terms of uppercase V for voltage, right? So, voltage divided by, I try to spell everything out as far as dimensions so you guys don't get confused. Distance, what it's measured in, and not distance, I'm sorry, meters. I don't know what I was thinking about. And this is equivalent to what else? Well, you gotta look at electric potential and what it's measured in. So that's the voltage again. So this will be voltage, and it's uppercase V here. This is voltage, and this is divided by what? Well, distance is in meters. So it actually is the combination it needs to be. Next is the equation itself. So that'll be E is equal to, for our electric field, uh, minus, remember I said that, and don't forget we got to use delta now. That's change in, and that's what that means. So go to insert, special characters, and we're going to use that delta feature we used yesterday. So we're going to go arrows, change it to math, and then type delta. And just choose one that you think is comfortable. Just choose a delta that looks like an uppercase delta, not a lowercase. So when you click on it, it automatically inserts it, and there it is. And V divided by, for our distance, is just lowercase d. So that's the technical equation we're going to use for calculating anything we need with these plates. All right, known and unknowns. I guess I got to put this in the chat, right, for you all. Known and unknown. Just make sure you edit everything correctly. We grab this first set of notes for you. This goes, we're working on problem 1S, everybody, in case you didn't know. All right, so that's the first set of notes. Make sure they're centered, like mine's are. Now, known and unknown values, right? What are they? If we go up here, you see the plates of a parallel capacitor are to a 12-volt battery. They're connected to that. So that tells you what? That tells you your delta V is 12 volts, right? All right. So let's put that into our calculation. And remember, it's going in a uniform fashion. I think this one has a trick to it. It's immediately a negative value because the way you saw the electric field going was downward. So you're going to put minus 12 volts there. Okay. So we'll grab this. And remember, this is our delta V part. Is equal to a negative 12 volts. That's the battery. Okay. Next is, what else did they give us here? Well, it looks like they gave us a distance, right? Part A, and it's two parts. We have part A and you got a part B here. So in part A, we can do, what is it? What is it? Part A asking, if the plates have a separation, what is the magnitude of the E field? We can find the E field and then find the electric energy, and that'll be PE. And I'll give you an equation for that in a moment. But first, let's do E, and that's our distance. Lowercase d is equal to, and you see right there, 0.75 centimeters. It's right here in the problem, everybody. So put d, lowercase d is equal to 0.75 centimeters. Automatically we got to change centimeters to its actual value. So centimeters, if you look up centa, It actually means times 10 to what? Anybody know what that means? What that would be? It's E right here. Let's say that was in volts. If you're not sure, that is going to be measured 10 to the negative second. Change this up. So it's going to be times 10 to the negative second. You're going to raise that negative second by superscripting. So this is the value we're going to use for our calculation. All right, so let me put this in the chat, and then we're going to talk about strategy. We're almost through with this problem, and we'll be ready for share outs in a moment. Okay, so that's the next notes, right? Make sure you separate your known and unknowns. Underneath your unknowns, I should see the value I gave you, E equals. And knowns, I should see all those values. Okay, so where are we at so far? Well, now we got to find out what the E field is, right? So strategy, because that was part A. Part A said, hey, figure out what the E field is. Part B is asking you for this equation here before I forget. So the next equation is that you need for change in, which is delta. So let me grab this delta. This is the old equation. So change in the potential energy, right, PE is equal to the charge Q multiplied by delta V. That's just another equation we're going to need in a moment. Remember when you saw on that chart, there was something called stored energy, and that's your delta PE. Now, this is known as change in potential energy. That's delta, all is one term, is equal to charge or amount of charge multiplied by delta V, which is what? We said delta V was our change in electric potential. So I'm just going to grab that. Okay. These are the notes for part A, part B. I'm sorry, everybody, in case you were wondering, what is he going with this stuff? So it's all the notes for part B. What is this measured in? Well, you would simply say it's measured for delta PE. It's definitely measured in joules, right? Q is measured in coulombs and multiplied by the delta V, which is just volts. All right, so let me grab this and put that in there for you as well. This goes with your centered notes. So let me just grab it all again so you have it in full perspective. And then we can jump into the strategy. I just wanted to get that in there for part B to be completed. So here's everything. Should show. And it does. Okay. So that's everything again, just in case you needed it. Now, unknown values, you had it. We'll put this in there again. And we got 20 minutes left, so let me hurry up. So we know, what are we looking for here? We're looking for delta PE here, right? So let me grab that. Part B. It's going to be measured in joules. Cool. All right, grab this, put that in there for you. That again is the known and unknowns, everything. Now, strategy, right? Let's knock this out. So strategy, use the First equation for the electric field, right? Not to calculate, just for the electric field, because that's what it is actually. Now, we take the equation. This is the equation right here, everybody. So I'm gonna grab that, come down here. That's the one I'm saying. Take that equation, the first one, and use it. Now we got all of our values set up in our knowns and unknowns, and all we gotta do is just put our numbers in there, right? So let's do that. The finish line with this problem, everybody. So we can't use, remember, 0.75 centimeters. We gotta use this value here. Okay. So let me grab that. I'll put that here for our D for distance. And for our delta V, or change in voltage, we said that was 12 or negative 12 volts. So go ahead and put that here. All right, so far so good. Some things will cross out and combine, and then we just divide. So let's see what happens. Now, understand there's a negative here and there's a negative there. So that's negative times negative, right? Because this is going to combine, make positive. So we can rewrite this, right? What is it going to look like? Well, I'm just going to show you steps. So the negatives go away automatically, because that's negative by negative makes positive. Volts and meters, they just combine. So we're going to cross these out and put volts meters on the outside. Let me just do that. Okay, and then on the outside of this, you'll have, what did I just mentioned, volts per meter. And let's bring it down one more and remove everything that's been crossed out. Okay. But now all you gotta do is just use MathPapa to calculate the next step, and then calculate PE. And then we're done, right? Okay, so let's do that. Let's figure out what that is. So
Wait, can you put that in the chat?
you said what? Put that in the chat.
Put that in the chat.
But okay. I was gonna put the next few steps, but all right. I'll put this little bit in here for you. She said that real quick. Glad you spoke up. I wouldn't have known if I was moving too fast. Like, there you go. But again, if it's in the chat, you gotta still strike stuff out. Like, it doesn't look right, So the bulk of it's in there, but clean it up. That's all I'm saying. So let me finish
I
up, because
know.
we got okay. So let me keep going, because there's a few things to go. We got part A and B to do, and we're almost through with part A. Part B is not bad. We just got to use what they gave us. There's two values we didn't mark off, because we're still working on part A at least. So what is this final answer here? Well, you just use MathPapa, like I said. So I'm gonna grab this, not one, and move this out. Put a question mark here, because now I'm going to calculate it. And here we go. Oh, here, I already had one open. Okay, so I delete all this jazz. There we go. It's simply what when you use MathPop? Let's type it in very slowly. So I would start off with parentheses, keep everything grouped, hit the divide button, and the first value is 12, right? Divided by 0.75 times 10, hold shift, press 6, and it's supposed to be -2, right? When I do that, I get about 1600. Okay. So I'll come over here, and the answer here is 1600 volts per meter. Okay. Real simple. Next is we got to calculate part B. And I told you part B, you're going to use this equation here. Okay. So This is the strategy for part A, in case you were wondering. And down here is the strategy we're going to do for part B. So I could just literally take this part and say, hey, do it for second equation to solve for change in potential energy. Okay, so let me do that. This is part B. And we're going to use the second equation now that we talked about. Okay. I'm looking at this clock. We're not gonna have time for share outs. We're just, I'm trying to give you time to catch up basically. But we could do share outs on Thursdays if you guys want to share your work from today and collect in-class points. Okay, but I want to get through this problem for you. Okay, and we're not solving for the lecture field here. We're solving for what did I just say? The change in potential energy. But it's actually the electric potential energy. But let's say potential energy. So delta PE. Now I got to say electric because we're using Q for charge. So electric potential energy. That equation is here. Let's come up some. Grab this. Come down and let's plug that there. Now there's a value we're missing. And part B, I'm gonna let you guys finish off. I'm gonna at least carry you through most of the steps. So let's take a look. It says it has a charge. Hint, hint, charge. That's Q. All right, so let me come down here. And in our known values, we're going to say Q is equal to, and what did they say that was? Let me go back and grab it. So they said that charge itself on part B is plus 6.2 times 10 to the negative 6 coulombs. All right, and it goes from plate to plate. That in there. This is going to help us finish the problem off. And we're going to also use it correctly. So let me raise this to the power of negative 6. The part B value, in case you're wondering. Okay. So now I can grab this and put this inside of this Q here. So let's do that. So Q is, we know what Q is. We just found it in part B, right? We'll grab it. And this is plus 6.27 times 10 to the negative 6 coulombs. Down here, plug it in. Then what is delta V? Well, we just calculated that, right? No, we was given it. That was at negative 12 volts, right? So let me parentheses negative 12 volts. And now I think that's done. We just got to cross some things out. Whew, I made it just in time. Give y'all a little time because it's like 10 minutes of class left almost. So coulombs crosses out here. And with, volts, they combine to make joules. Okay, so let me see. What is that going to be? That's going to be, let's grab this. I'm going to cross this out. And then we're going to cross out volts. And lastly, on the outside of this, you'll get joules, I just mentioned. So clean it up. Yes, I know. So when we clean it up, we get only this and only this. Your goal is to calculate that using Math Papa. I took you through 90% steps. And yes, before you say it, are you going to put that in the chat? But I advise you guys on, did I put that part? Did I give them that part? I gave them that part. So let me try to put part B in there. I'll put both parts in there for you guys. So part A, this is everything. Right? And then part B, this is everything. But you have to calculate the final answer for joules using Math Pop, okay? Forget to do that part before you can call yourself done. All right, so I think I did great. It's 111. or 1111, not 1111, sorry, 111, I was right. Uh, is there any questions? Did you need me to scroll up? Did you miss something? Or does anybody feel confident enough to share out for in class points? You should have your simulations done, which were these pictures we did here, right? So these two somewhere at the bottom. You also have to do the same thing to 2A. I don't want you guys forgetting. There's a second problem, but it's the same setup. You just change the values. If you get stuck on it, bring it to class on Thursday, and that's the day we use for asynchronous. Okay, Stevenson left. I didn't say leave. I just trying to make sure y'all was straight. All right. So I want everybody to, if you're not ready to share out, work on it for the next 3 minutes, and then you'll be free to go. Okay. Please try to get some of this typed up. In the computer.
That last little part, can you put that in the chat of the last one? Of
I
the,
did. I did.
you
Put
did.
yeah.
What can you write on the chat so I can see it?
You said what now?
Write something in the chat so I can go to the chat.
Oh, okay. About that. Did that work?
Uh-huh.
Okay. Yeah. So try to get all these notes, everybody, because you need to turn in. David, are you straight over there? Did you get everything you needed? Hmm. Okay. Sharon, are you there?
Yes,
Was you able to get all the notes?
yes. Well, I wrote them down.
Okay. You typing them up now, or how you doing that?
You say what?
I said, was you gonna type them up later or something, or how you gonna do that?
Yeah, cause my leg broke and my arm broke too.
Oh wow. Okay. All right. Well, do your best.
Mm.
113. David, are you there? Were you keeping up with me, or did you step away?
Yeah.
Yeah. Okay. Okay. So is anybody ready to share their screen, or because it's 116 now and class is almost over? You may want to get their in class points, or still working on it. What's the deal with you all? Richardson, you there?
Yeah, I'm here. I'm for the show.
Oh, you finna share? Okay, let me turn it on. I'm sorry. I don't know if you're sharing or not. Okay, so you should be able. Yeah, it is on. You can share. Let me stop sharing so we can see what you did. All right. Are you okay? Is it letting you share or no?
Yeah, I finished. I'm doing it right now.
Okay. There you go. Okay. Oh, okay. 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 Oh, all right. Now, how are you gonna do the simulation screenshots? Did you take those? Where's those at? Oh, she stopped sharing. Okay. All right. Well, you got a good number of points 'cause you got most of the notes. David, what about you? I see you're back in the camera. Oh, she's presenting again. Okay. So you got the screenshot. Oh, you do have. You got the screenshots. Okay. So if you can, just submit those screenshots with your assignment. Okay. Download them into Etsy with your assignment today. David, do you have anything to show? Like, what do you?
Okay. Can I leave?
Yes, you're free to go.
Okay.
David, and
Yeah,
Sharon, you guys have anything? Hmm.
I do.
Okay. Can you share your screen?
Yeah.
Thank you. There you go. Okay. You got to show me the screen you want me to see. Screen is just black there, Dave. Okay, you stop sharing. I couldn't see anything though. You're like, can you share again? Like, I think you might not have shared the right screen. Couldn't see your work at all. Okay, sharing left. Okay, there you go. You're presenting. All right. So it says presentation David Concepcion. All right. Well, what I want you to do is I want you to try to download it and send it to me in Edsby, okay? Because class is over with. But you do get points for trying to present. Did you hear me, Dave, or no? Yes, I know. I know Google. There you go. So, Dave, class is over. Just try to submit it to Esby so I can grade it, okay? Whichever you have done. We'll talk about it more on tomorrow. David, are you there? You like frozen? Okay, okay. All right, Rush. I will see you later.
Hey, quick question.